In this video, I'm going to implement linked lists in Python, a different function of linked lists, starting from the insert as starts, insert at a specific index, delete from starts, and so on. So I'm going to explain every step along the way. So let's begin. So first, let me write a comment. Let's call this creating node. So let's create our node class. Let's call this class node. Then our init function. Init. This taking an argument of data. Self dot data equal to data and self dot next equal to none. So what we did here is we created a blueprint for our linked list or our node class. So just like I explained, linked list consists of nodes connected with each other using links or references. So each node consists of the data field and the next field. The data field contains the data or the value of each node, and the next contains link or reference to the next node. So we just created a blueprint for our node class. Let's proceed to create linked lists. So let's do this. So let's make a comment here. Let's call this creating linked lists. So class linked lists. Let's create our init function. So let's call this self.head equal to none. So what we did here is we created a blueprint for a linked list. In linked lists, the linked list always starts from the head. So from the head, then we create the next node down to the tail node. So in this class, we created a blueprint for a linked list starting from the head, and we initialize our head to be none, meaning that at this point the linked list is empty because the head is none. So let's start inserting node in our linked list. So let me make a comment here. Let's call this inserting nodes. So let's create a function. Let's call this insert at start. This taking an argument of data, then node. I'm going to explain every step along the way. Data node dot next equal to self dot head. So self dot head equal to node. So what I did here is I created a function called insert as start, and this function taking an argument of data. So when we call this function, it passes this data to the instance of our node class here. So on line 15, we created an instance of our node class called node. We're passing this data received from our function here. So when we pass in this data we pass to our node class here, and the value is assigned to this data field. So the data field holds the value for our linked list, and the next holds the reference to the next node. So on line 16, where we said node.next equal to self.head. So at this point, we are trying to create our first reference. But since at this point we have only one node, which is the head node. In fact, at this point we are yet to even assign our head node to be this new node. So by this point, we only have one node. So the next value or the next field of this one node will be none because there's no other next after this. So what we did here is we initialized our next field to be the current head, and the current head is none. Exactly. We initialize our next field to be the head, the current head, and the current head is none. So when we create our, let me call this none here, none or none. So when we create the next node, we are going to make reference to this next and assign the value of this next field to be the new node we created. So just like I explained, we have a linked list, we have nodes like this, right? So each node consists of data and next. So we've created our first node. This is our head node. So this next field here is none because there's no next node yet. So here is none. So when we create this next node, you're going to make reference to this previous node and assign the value of this next field to be the reference of this new node. So that is why we have none here. So let's proceed. We will understand this when we get to the next node. So on this line, we are officially assigning our head node to be this new node. So this is where the new node becomes our head node. So by this point, the head is none or null. So by this point, the head becomes the new node. So let's proceed to create a traverse method, traverse linked list. So what this method does is, this method traverse or loop through our linked list starting from the head down to the tail and print the values of each node. So let's make a condition. If self dot head is none, meaning if our linked list is empty, then print the linked list is empty. Then we'll return from this function. Else, we'll loop through our linked list from the head down to the tail and print the value of each node. So let's create a variable and call this traverse and assign our head node to be this. So while traverse, meaning while head exists, we'll start looping from the head down to the tail. So while head, print traverse dot data, and separate each value with a pipe symbol. Then update our traverse to the next node. So what we did is, we say while traverse, print traverse.data, which means print the value of our head node here, and separate it with a pipe symbol. Then on line 27 here, we are trying to update the value of our traverse from head to the next. So the next now is the next node. So here we say traverse equal to traverse.next, meaning after the head, start from the head, loop through, print the value of the head, then go to next by updating the traverse variable to next. So we'll go to next, print the value of the next, separate it by a pipe symbol, then go to next. As I'll loop through up until the end of our linked list, then we'll print a space for that. So let's try this and see. Let's create an instance of our linked list. Let's first try the traversed linked list and see if it will print the linked list is empty or loop through it. So linked list dot traverse. So let's run this and see. So we have the linked list is empty, and the reason is because as at this point we are yet to add our linked list node or node in our linked list. So let's add our first node, linked list dot insert at start. So let's insert mango. Let's also insert start. Let's insert orange. Now let's run our linked list and see. We have mango, orange, and mango, right? So orange becomes the previous head, while mango becomes orange becomes the new head, while mango becomes the previous head. So let's define other functions in our linked list. Let's create a function that deletes node, or that inserts node at the end of our linked list. So let's call this inserts at end. This takes in an argument of data, and let's define that. So let's say node equal to node data. So we're trying to create an instance of our node class here. So let's give some conditions. If self dot head is none, meaning if linked list is empty, then let's call in this function insert at start, then pass in our data, then return from this function. So if the linked list is empty, then we'll call this insert at start and insert this new node to be the head node. Otherwise, else we'll loop through. Let's call this last, equal to self dot head. So while last dot next exists, we'll loop through this, that is last equal to last dot next, and after looping through, then we'll add our node here. So let me explain what we did here. So we created an instance of our node class here. We're trying to see if this linked list is empty, that is if self.head is none, then we call this insert at start function and pass in our data to create our head node. Otherwise, that is if the linked list has some node before now, we'll loop through the linked list starting from the head. So here say while last dot next exists, which means while there's next node, keep looping. While there's next node, keep looping. So we'll go to here, update it to while there's next node, loop again up until we get to the tail node. Then we'll break out of this while loop and insert this node to be the node of the tail, that is the tail node. So let's try this and see. Let's change this to insert at end orange. So let's call this function and see. So we have mango as our head and orange as our tail node. Let's add extra node and see. So linked list dot insert at end. Let's call this cashew. It is fruit. Cashew. Let's also add linked list dot insert at end. Let's call pawpaw and run our code. See. So we have mango, orange, cashew, and pawpaw. So this is the insert at end function. So let's proceed to create other functions in our linked list, like delete from beginning. So let's define the function and call this delete from beginning or delete from start. And let's give it some conditions. If self.head is none, meaning if linked list is empty, then return the linked list is empty. Otherwise, that is else, we delete it is self.head equal to self.head.next. Now let me explain what we did here. So now this is our head, right? So this is our next node, then the tail node. So now we're trying to move the concentration from this node, which is our head node, to the next node. And that is why we wrote if self.head is equal to self.head.next, meaning we've changed the head node from the head, the current head, to the next node. So we say self.head is now self.head.next, meaning the next node is now the new head. So I hope this is clear. Let's proceed to creating other functions like delete from end. At least we're trying to delete the tail node, right? So in this case, let's give in some conditions. Let's call this if self.head is none, then return the linked list is empty. Another condition, if self.head.next is none, self.head is none. So let me also do this. Otherwise, traverse, let's create a variable called traverse to self.head. Then while traverse next exists, look to traverse next. Let's update our traverse with traverse equal to traverse next. So while doing this, we'll call traverse next equal to none. Okay, so here we created a function called delete from end. So now we give a condition: if set.head is null, meaning if there's no head in the list, which means the list is empty, then return the linked list is empty. Now if set.head.next is none, meaning if there's no next, that is if self.head.next, this is self.head, this is self.head.next, this is self.head.next.next. So if self.head.next is null, meaning if there's no next node, then we'll change this to, so if there's no next node, then we'll now render the head to be none, meaning if there's no next node, we'll delete the head of the node. So otherwise we'll loop through or traverse from the head down to the tail and delete the tail, but this is how we do it. Now while traverse.next.next, meaning we loop through the node 2 nodes before the node we want to delete, right? So while traverse.next means the next node .next exists. So let me do this like this. Let's say we have A, B, C, D, E, F, G, H. So now we say while traverse.next.next, let me comment this out so that we won't have error. Why this exists, meaning now we are starting from the traverse.head, so this is traverse.head here. So while traverse.next.next exists, traverse.next.next exists, then we'll update our traverse now from the head down to this. So this becomes the new looping point. So also try it again. While traverse.next.next, meaning while this is head traverse.next.next, and this is the new traverse. So while next.next exists, update it to be G, right? So now the question is why traverse.next.next. So in this case, there is no next.next. So we only have .next. So this is what we're trying to delete. So down to this line, we're trying to say since there's no traverse, we loop through up until we get to this point. So since there is no traverse.next.next at this point, we only have traverse.next. It will break out of the loop, which is here, and render this next as traverse.next, because this is our current traverse here. So now say traverse.next is none, meaning we are deleting the last node. So let's also implement this and see. So let's call linked list dot delete from end. So now we're trying to delete purple here. So let's run our code and see. You can see there's no purple here. So we have only mango, orange, cashew, and no purple. This purple is the end of the list. So let's proceed to create other functions in our linked list, like the insert values. That is, insert multiple values. If you want to insert multiple values, so let's call this insert multiple values. So this takes in a data list or an array. So let's loop through for data in data list. So let's loop through this data list and call this function insert at end. Insert at end with our data here. So we're trying to loop through this data list and insert each item or each data to the end of the node by calling this insert at end, then passing the data here. So let's create this function. Let's comment this out and create a function that's do this, then insert multiple values. So let's pass in an array of multiple values. Let's call this strawberry, then let's call in pineapple, let's call in grape. Let's try this and see. So let's run our code. See. So you can see we have our first fruit as mango, second fruit as orange, cashew, pawpaw, strawberry, pineapple, and grape. So this is how to insert multiple values in our linked list. To create another function that gets the length of our linked list. So let's call this get length. So let's do this now. So let's initialize a count to be 0. Then head, we're trying to loop through. Go to self dot head. So while head exists, it is why this loop contains the head. Then we'll keep counting by going to next. Then after counting, we'll update our count to be this. Then we'll return count. So let me explain what we did here. So we initialize the count to be 0. We start looping from the head down to the next node. So each time we go to the next, we'll increment our count by 1. Then we'll go back again and go to next and keep incrementing our count. Then after counting the whole node, we'll return our count. So let's try this and see. Let me do that here. Linked list dot get length. So let's print this. Since we are returning the value, let's enclose it in a print function. So let's run our code and see. So you can see we have 7 as our length of our linked list. So let's count it and see. We have mango 1, orange 2, cashew 3, pawpaw 4, strawberry 5, pineapple 6, and grape 7. So if I add more fruits, let's call this pear. I believe there's a fruit called pear, right? So let's run it and see again. So we have total of 8. So this is how we implement a function that get the count or the length of our linked list. So let's also implement the next function, which is called remove at a specific index. So let's call this remove at index. So this will take in our index as our argument. So let's give you some conditions. So if index is less than 0 or index is greater than or equal to the length of our linked lists, then we'll raise an exception. This exception invalid. So close this now in brackets. Invalid index. Now another condition, if index is exactly 0, that is the beginning of our linked list, then let's call the insert, and let's put this in our as our head node, right? Or let's remove our head node. So self.head equals to self.head.next. So then we'll return from this function. So let me explain this before I proceed. So we give a condition if index is less than 0, meaning if you pass in -1, -2 as our index, return or raise an exception called invalid index. Or if index is greater than or equal to the length of our linked list, raise an exception. If I pass in 9, our linked list has a length of 8. If I pass in 9, that means you're passing in an index that is bigger than the length of our linked list. So raise an exception that this index is invalid. Or if I pass in exactly 8. Now mind you, in programming, we start counting values from 0. So indexes start from 0, which means our cashew mango here becomes 0, orange 1, cashew 2, 3, 4, 5, 6, 7. So not 1 down to 8. So if I pass in the length of our linked list as 8, then it means the index is invalid. It's supposed to be 1 less than the index. So then the second condition is if index is exactly 0, that means we're trying to delete our head node. So change the reference from the head to the next. So the self.head.next becomes the new head. Then return from the function. Otherwise, let's loop through, let's create an iterator called the self. This can be any name. I just choose to call it iterator self.head. So while iterator exists, then let's also give it some conditions. If count is equal to index -1. Okay, we're supposed to initialize our count here. So let's initialize our count. Let's call this count equal to 0. So if this count is equal to index -1, I'll explain this. Let's write this function iterator dot next equal to iterator dot next dot next. So what we have in here, so then break, we have iterator is equal to iterator dot next, then increment our count is equal to 1. Okay, so what we have in this here, so we're passing our index here. So let me try this and see. Count equal to index -1. And do this. Now let me explain what we did here. I'm trying to delete a node at a specific index, right? So we are supposed to count to a node before that index. I don't know if you understand. We're supposed to count a node one step before the specified index. So for example, if you're trying to delete, let me make some illustration here. Let's make some comments. Let's call this A, B, C, D, E. Then F, right? So let's also do this here. So this is 1, this is 0, right? So this is 1, this is 2, this is 3, 4, 5. So you're trying to say if counts, so if you count from 0, 1, let's say you want to remove the node at D, so you're supposed to count up until node 2, because node D is at index 3. So count up until node 2, that is if count is equal to index minus 1, that's we're stopping at 2. Then we'll do this. Then we'll say iterator.next equals to iterator.next.next. We're trying to remove this index. So what we'll do is when we get to this index 2, that is C, we'll now change the reference from being D to E. So that's why we say iterator.next. That is iterator.next, C.next will not be this. It will not be iterator.next.next, meaning iterator.next.next, iterator.next.next. So we're trying to remove this, so we'll stop at E here. So iterator.next.next. So we'll change the reference from this C to E here. That is what we did here. We'll break out of the loop. Then in line 81, you're trying to say continue looping until we get to this condition. So when we get to, so we're starting from 0. So this is 0. So and 0 is the head. So y head is head the index, no. We'll jump to this point to update head to be the next, meaning B. We'll keep looping up until we get to this point. So each time we go to the next or the loop, increment our count. This is how we remove at specified index. So let's run our code and see. So let's do that here. So linked list dot remove at index, let's call this index 3. So index 3 is D. So let's run our code and see. Now, so in this let's count. This is mango is index 1, 0, orange index 1, index 2, index 3. So we're trying to remove purple. I've removed purple here. So if I change this to index 4, which means strawberry. So let's run and see. I see remove strawberry from purple, then remove strawberry. We change to pineapple. This is how we implement a function that remove a node at a specified index. So let's go to the last function to implement, which is insert a node at a specified index. So let's call this insert at index. So this takes in an index and the data we're trying to insert. So let's create an instance of our node class here. Let's take in this argument of data. So let's give some conditions, same conditions. If index is less than 0 or index is greater than or equal to self dot get length, then raise an exception of invalid invalid index, right? If index is exactly 0, meaning the head of the node, then let's call in insert at starts, because index is 0. Let's pass in our data argument. So if this are not the case, then let's loop through our index by initializing our count to be 0. Then let's define an iterator that iterates our, so let's call it self dot head. So while iterator, while iterator exists, then let's also pass in a condition if count is equal to index minus 1. So just like I explained before, one index before the specified index. And let's do this. Node dot next is equal to iterator dot next. Then iterator dot next is equal to node. So I'm going to explain what we're trying to implement here. Iterator dot equal to iterator dot next. So let's increment count plus 1. Okay. So why these both conditions are not true, and let's initialize count to be 0, iterator equal to self.head. So while iterator, meaning why there's head in this linked list, then we'll give you some conditions. So when we get to an index, when the count get to an index before the specified index, that is 1 before the specified index. So we'll do this. So let's do this. So we are trying to insert a node in between these two nodes here. So when we get to this index, that is 1 before the specified index, right? So this is the specified index in between. So we're trying to insert a node here. When we get to this index, then we'll change the reference of this next to be the new node we added. Then change the reference of that new node to be this other node here. It is the last node or the next node. That is why we say node.next. That is the initial node now. Node.next is the iterator.next, meaning the node we are adding, right? So now officially the iterator we added now will be the new node. So we've changed the reference from the initial node to the new node and change the reference of the new node to the next node. So we keep looping through up until we find this condition satisfied, then implement this. Each time we loop through, implement our count. So this is all for, so let's implement this and see. Index at space index. So let's do this here. Let's comment this out. Then let's link list dot insert at index. Let's call this index 4. So we have 0, 1, 2, 3, 4. So between pawpaw and cashew, we're trying to insert. Let's call this which fruit. Let's call this which fruits. Let's call this, we have orange, you have cashew. Let's call this I don't really know fruits to insert here. Okay, let's comment orange out. No, let's, what fruit do we call this? Let's call this which fruits. We have I think we have coconuts. Yes, so let's call this coconut. So let's run our code and see. We're trying to insert coconut in between. This is 0, 1, 2, 3. So in between pop and strawberry. Let's run our code and see. We have coconuts in between purple and strawberry. So if I change this to insert at index 5, so in between strawberry and pineapple, let's run this and see strawberry and pineapple. So this is correct. So this is all about implementation of linked list in Python. So I hope this is clear enough. If you have any question or comments, kindly drop in the comment section below. I'll take our time to answer every questions there. So in the next video, we're going to be implementing hash table in Python. Just like we simplified this, we are going to simplify implementation of hash table in Python for absolute beginners. So I hope you enjoyed this video and you've learned a lot from it. If you do, kindly click on the like button, comment, share, and most importantly, subscribe to this channel for more videos like this. Thank you.